Hello everyone. Today I'm gonna represent you what we learned during integrating technology in math education class. This class contains many topics, but the main idea of this class is how we can integrate the technology into math education, how we can make a better class for students, and how we can let them understand very clearly with technology using technology. So we have, first of all, we have some activities, and in activities there are questions. Uh, we will glance those activities. Uh, those are the questions that we solved in the class. So let's get started. First of all, in first activity, there are three questions which says we have 500 trees and we're cutting down 8% of them, and we are planting B new trees. So the limit is 250. So let's see in the first question, relationship, find the relationship between A and B. Let's remember the formula first. A formula is limit times cutting down how many how like percent of number of percent of A divided by 100 equals B. So if we do the calculate, relationship between A and B is 5A equals 2B. So basically A equals 100 and 2 equals 250. B equals 250. So for second question, we have to create a table for each year, which shows approaching from 500 to the 250. For third question, it says start with 100 trees and show that limit is approaching 250 again. So if we remember the calculate, if we look at the calculate, we are not dealing with the starting point, so we just deal how many trees that we cut and how many trees that we are planting and what is limit. So we are not dealing with the starting point, so that we don't need starting point, actually starting point, so result will be same. This is the first activity that we solved during the class. For second activities, we have a patient in hospital, and we are giving 200 cc of a drug, and after 1 hour 75% of the drug has left, and we are giving after 75% of it leaves, we are giving 30 cc of drug. So if we do the calculate, limit is answer times 0.25 plus 30, because after 75% of drug has left, which means 0.25, I mean 25% of drug has remained. And we are adding 30 cc of it. So we started with 200, and it will, if we make a calculate, it will become 80, and it will become 50, and it will become 43, 41, and comes 40. So our limit is, and it will remain in 40, so our limit is 40. And 250 is initial size, 0.25 is the percent of the how many drug that we have remained, and 30 is number of new drug. Another activity is that it says enter any positive number, integer or non-integer, large or small, into your calculator's display. Press the square root key, press the square root key like 15 or 20 times. If we do this, let's say let's start with 100 or 550, whatever we choose. If we start square root key, it will after 15 and 20 times, pressing after 15-20 times, it will come to 1. If we choose the numbers between 0 and 1, it is getting it is approaching 1 again, but this time it is getting approaching 1 as increasing. The previous example, actually, if we choose positive number, like other than 0, between 0 and 1, if we choose any number, it will get approaching 1 as a decreasing. But if we choose a number 0, between 0 and 1, it will approaching 1, but this time as a increasing. For this activity, let's choose 50 plus 1 equals 51, divided by 2, 25.5. Let's click enter many times. It is getting it is approaching to 1. It is approaching to 1. Let's do it again. 50 plus 1 divided by 2, as you can see. So the limit is, yes, it is 1. Let's choose smaller than 1. Let's say 0.25 plus 1. Let's choose 0.5 plus 1 divided by divided by 2. It is getting 1 again. and of course let's choose 1 plus 1 divided by 2 is getting 1 again. For this activity, we will make a square of positive integers from 1 to 10 first, which is 9 digits, starting with 0 and ending with 9. It is asking relative frequency tables actually. If we do the calculate, the table will be like this and the percentage will be like this. So it wants to, we have to do it for 1 to 10, 1 to 20, also 1 to 30. The percentage will be same, but number of relative frequency will be for 1 to 12 or to 20, it will be 2 times number of elements, and for the 1 to 30 it will be 3 times number of these elements. So the percentage will be same thing, but relative frequency will be 2 times and 3 times. It will be like this. For this activity, we have to make a cube of integer numbers from 0 to 9. So if we do the calculate, there is a 1 number of digits from each digits. So relative frequency is 1 for each digit. Percentage is 10%. If we do it by one for 1 to 20 and 1 to 30, it nothing is gonna be changed, just the relative frequency. We have to multiply with 2 for 1 to 20, we have to multiply with 3 for 1 to 30. Percentage will be same. This is the also graphic and numbers of actually value of the numbers between 0 and 9. Square root of 4, and last digits and frequency, numbers and relative frequency. And here is the chart for the if you click on it, numbers and relative frequency, as you can see. So we try to solve the question, actually resolve the question that we solved during the class. And also in this class we have learned how to use GeoGebra in math education. GeoGebra is like one of the tools, technological tools in math education. It is very useful and it is really understandable. We have also we had some activities with GeoGebra application. during this class. Um, First of all, we called box plot. It is for these activities we had a list here, as you can see. You can work on algebra, graphics, spreadsheets at the same time in GeoGebra. So we have a list. This activities shows how to find a median, mean, variance, quartiles, giving list. So we have a list here, and list 2 is most number uh, most number most number repeated. So 26 is the repeated 2 times. So list 2 shows that. So mean, if you click 2 times, double click to A, it shows mean list 1. Just input here. You can put you have to put mean of list 1 for to find mean, and B is the median of list 1. It is same thing for B to find the median. C is histogram for list 1. D is box plot for list 1 again. E is quartile 1 of list 1. F is quartile of list 3 again, and H is variance of list 1. So it is, you can like these activities shows that we can find median, mean, variance of given list, so that we can work with GeoGebra in math education. For these activities, we will find it shows how to find a derivative of a function. So we have a function of fx. There is an input here, as we did in last previous activities. Just put input, which is fx. Three three plus 2 x 2 minus 6s plus 5. And just write g x equal derivative of fx. It will automatically gives you a gx which is derivative of fx. If you click on it, object properties, you can rename it derivative, for example. So this is basically how to find a derivative of a given function. For this activity, we will learn how to find the area of integral. So we have a given function again from input, and we have a slider from here on the top. And we have an upper sum from input again. If you write upper sum, it will give you a function first, start x value, end x value, and number of rectangles, and you will write, when you click on it, function is f minus 3 minus 1 and a. So when you create a slider for the minimum 1, maximum we gave 200. So if you make it bigger and bigger, as you can see, it is getting rectangles are getting closer each other, so that you can see the area of integral. So it is basically how to find the area of integral. When you scroll down, actually to the right, so when you make it bigger, you can see the area of integral. For this activity, which is named projectile motion, we have two images. The ball, which is important image, if you right click and then object properties, when you go to position, you will see the formula for corner 1, corner 2, and corner 4, and we created a slider which is V and T. It is when you move V and T, you can see the ball is going up and going down. If you make it also angel, we created a angel, which is slider again. If you move it, you can see the changes. And with this activity, you can let students understand very clearly how is changing, like how does it affects when you change angle, and when you make more speed and time also. So this activity shows that we can understand very easily if we see the movement while we are trying to solve the question. In these activities we will find the line of best fit. So we have two datas, actually two tables. One of them is year and one of them is number of business, as you can see in the spreadsheet. So list 1 is the number of business and list 2 is how many business that is done in each year it shows. And here is the points that we created. For the line of best fit, you have to come and write input in the input area, which is line point. If you put the points, for example 2003 and 754, and if you give if you put every point, and it will give you automatically line of best fit, which is line A we called here. In this example we will find the car, like how long it takes to go to from A to B. We will find it. This helps to find how long it takes to go from A to B. So we have an image again, which is car here, that we created. And object properties, you have to see position. In position again, there is a formula here, and the points that we created. So and also slider here, which is V and T. When you as you can see, when we move the V and T, car is moving, and you can find you can enter any point and you can find how long it takes to go from one point to another point. It is also helping, like when you see the activities, students can understand very easily. In this activity, we see the we called sin and cos. We have two function here, which is gx green and hx red, and with the input we found first sum of h and gx. So also we have a slider again here, and with the object properties you have to enter minimum and maximum value of each slider that we did, like we did during the class. So when you change the sliders, even one of them, it will change when you make it different. If you change the green one, gx changing and sum is changing. If you change red one, as you can see, red are changing, red line is changing, and the blue line is changing because of the sum. So this activities shows the values. If you change the values of sliders, it will automatically change equation, and it will automatically change some of the functions. This is the end of the video. I tried to represent you what we learned during this class, and we used a lot of tools, and we had some activities, and we have some activities with GeoGebra too. This class helped me to use technology to help the students how they can understand easily, and how how can we make a better class for them. And I used GeoGebra many times, and I really like the application, and it is very useful for students who is dealing with math, and it is very understandable. Thank you for watching my video. See you.